All right. We got the button right. We hit the wrong button. Phosphor is here. What's up? Welcome from Germany. Great to see you in here. Pavel is here. Welcome. Second time catching the live stream. All right, Joho, welcome. Thanks for joining us. Great to see everybody in here today. Beautiful Monday, October 9th. Man, we had a good set of matchups this weekend. It was intense, man. I think that match between Jihan Rafa and Jack Sato is going to go down in infamy. It was really intense. We went 4 matches. We had matches that literally came down to the last second opportunity to enter and answer. So really cool matchup there between Jihan Rafa and Jack Sato, and great match between Pranav and Joush as well. Joush was the last remaining inventor user, and he got knocked out of the tournament. So we got no more Joush, no more inventor. We are down to just, I think, 3 CAD systems. We got SolidWorks, Onshape, and Ansys Space Clean. So really cool weekend. Striker says, how did the rematch go, Toby? Did not catch it. It was awesome. Yeah, it was Victor K versus Will once again. Victor K took it in 2 matches. Will had a real heartbreaker on the first match. He had the correct answer showing on his screen, but typed it into the YouTube chat incorrectly. That became known as the Tom Smith fat finger move. Yeah, unfortunately, we just have to take whatever the first answer is. You know, whatever the answer is in the YouTube chat, that's what we take. And that was his second attempt. So he did his first attempt, he missed a fillet, and then he found the fillet, did his second attempt, calculated the mass correctly, and typed it into the YouTube chat incorrectly. It was brutal, man. I did not want to see that match end like that. He was ahead. He got done with the model before Victor K. But that's the way it goes in the World Championship of 3D CAD. And then the wheel delivered him a sheet metal part as his second part, and that was doing him no favors either. So unfortunate, but it was Victor K who was able to move on. Old friend of the show. Always happy to see him moving forward in the tournament. All good, all good. Francisco is here. Welcome from Spain. Thanks for joining us. Hello, hello. Welcome, welcome. All right, guys, let's get into it here. Let's just do this. Let's just get right into it. I'm going to assume that everything sounds good. Everything looks good. Like I said, really good matches this weekend. Pranav versus Joush. Joush was the last remaining inventor user, so now we're down to just SolidWorks, Onshape, and Ansys Space Clean, I believe. Hopefully I'm not missing anything on that. And the match between Jack Saito and Jihan Rafa was absolutely epic. It went 4 matches. We don't usually get to have 4 matches, but we got to have it in that matchup, and it was really, really cool. Really, really fun live stream on Saturday, October 7th. If you didn't get a chance to watch it, go back and watch it. It was a good one. And that basically sets us up for the Elite 8. We now are down to just 8 runners. So pretty cool stuff. But let's talk about what we're doing today. Today is Model Monday Live, and as always in Model Monday Live, we do 2 CAD speed modeling challenges, and we do some live solves using Onshape. So here's the models that we've seen over the past, it's really like over the past 3 matchups, because we had the rematch. So we had this matchup here between Will and Victor K. This is number 57. I'm showing you guys these because if there's any one in particular you want to see, let me know, and I will definitely go over that. Will is in the chat. He says, oh no, yep, this is the one that gave Will, I'm sure, nightmares after the live stream was over. This was the one from last week. So if you guys want me to model this one in Onshape, I will. This is a sheet metal part. I would love to model this in Onshape. So if nobody says anything, then I'm going to do this one 55. So that first one was 57. This is 55. I'm definitely going to do 55 in Onshape just to kind of challenge myself a little bit. We've got this one here, the counter shaft. This is number 56. If you want to see me model this, I'd be happy to do it. Number 53, the socket. If you'd like to see me model this, number 53, let me know. Number 59, the duct. I'm definitely going to do this one as well. Our runners did not finish this one, so I'm going to model this one up for all of you today using Onshape. And number 41, the support base. Number 58, the housing. And Airwork says, I did that one, number 55. There's definitely an interesting bit in that one. Okay, cool. Yeah, we're going to definitely do that one in sheet metal. Yep, in Onshape. Number 58, the housing. Very, very fun model. Definitely some tricky elements to this one. And finally, number 61, the tri-cap. So lots of models here for you to look at. You can roll the video back if you want to pick out one that you want me to model. Otherwise, I'll just model the duct and the sheet metal part, and then we'll see if we have time for any other ones. So I just wanted to show you them before we got started. As always, the best way to support this channel is just to like, comment, subscribe, and also to share and reshare. Anytime you can share and reshare, That is a huge help. If you see me advertise for the live stream, or if you see me putting out stuff for the tournament, just take it and share it around in your social network. It really, really helps to grow the channel. And we are definitely in the growth phase. We're about to hit 9,000 subscribers here on YouTube. So we are chugging away here, and all metrics are pointing in the correct direction. So everything is good, and we just got to keep on growing it. All right, so here we go. Here's your first speed modeling challenge. I'm going to show you a 2D print, and I'm going to challenge you to turn that into a 3D model. And your goal is to calculate the mass of this model and to enter that mass in the YouTube chat. Now, the basic rules of this challenge are that you can use any CAD package as long as you can input a density and output a mass. Use the specified precision that is on the print, and the first correct answer in the chat will be declared the winner. Here's the units that we use. We use either IPS, inch, pounds, and seconds, or MMGS, millimeters, grams, seconds, and we ask for the weight in either pounds, grams, or occasionally kilograms. The materials that we use are coming right from the SOLIDWORKS library, so if you're using a different CAD system, your library might be a little different. Just make sure that you've got the materials mapped with the density that is shown on screen at the moment. And the advanced rules are that this is meant to be fun and good-spirited. I will make mistakes from time to time, and the Ivan exploit is permitted in this challenge. So if you can find a spot to use it, do it. But if you don't want to, don't do it. Just do it the right way. No offense, Ivan. All right, here we go. This first CAD challenge on this beautiful Model Monday, October 9th. Let me just adjust my screen a little here. Make sure you guys can see the whole thing. Stand by. Stand by. Okay. This first CAD challenge begins in 3, 2, 1, go. Okay, we're going a little old school here. We're going back to 2021, some of the old files before the purge. So here we go. What is the mass of this part in XXX grams? The tolerance on this is plus or minus 2 grams. The general notes here is the material thickness is 3 millimeters and the default bend radius is 3 millimeters. Now, there's a little bit of awkwardness, I guess you could say, with regards to that upper tab. You can see that tab pretty clearly in the isometric view. If you really, all you can do is rely upon the 80 millimeter dimension that's in the top view twice. It's in the top view twice, and also in the front view, to kind of help you figure out where those flat spots are on that upper tab. And then as far as the rest of the geometry goes, you just have to look at the hidden lines in the top view and realize that the that tab up top follows the exact same curvature as the main bracket if you're looking down on it directly from the top. So that's kind of your hint, your guide on this drawing. If I were to make this drawing today, I would make it just a little bit different. I'm sure I'd have a couple of magenta notes on it. Maybe have like an extra view looking down from the top, or maybe make that top view shaded. But you know, you can solve this. I did test it. I did make sure that everything you need is there. You just need to kind of use your mechanical intuition, your engineering intuition, to figure out what's going on with that upper tab. One last thing I just want to say to everybody is that this is designed using sheet metal, and you can certainly do it using sheet metal, but you could also do it just using solid geometry if you wanted to. If you're using solid geometry, the inside bend radius is going to be 3 millimeters and the outside bend radius is going to be 6 millimeters. It'll be 3 plus the 3 material thickness. So if you want to, you can model this just using solid features. But I think you'll find it'll be a little bit easier if you do it using sheet metal. And if you're getting used to sheet metal, it'll be a nice little challenge, nice little practice model for you to try to learn how to do this using sheet metal. Not everybody knows how to do the curved geometry right in the sheet metal. So this would be a good chance for you to practice that. All right. I hope that was enough time for everybody to grab a screen capture of that challenge, to move it over into your second monitor, and to begin creating that using your 3D CAD of choice. I'm going to talk a little bit about the tournament, and then we are going to get into some Onshape CAD modeling, because these days Onshape is my 3D CAD of choice. So Let's talk a little bit about the tournament here. Guys, we're in the Elite 8. I made a little promo video this morning letting everybody know. Here we are, the Elite 8, the final 8 people. Basically, we're at the bracket championship for each of these brackets. So here in the black bracket, we started way back on July 15th. And now here we are, October 21st. We got the Golden Spamfish using Onshape. We got Ivan the Reasonable using SolidWorks. And whoever wins that match is going to essentially be the champion of their bracket. They're going to move through their bracket. They're going to be declared the champion of the black bracket. So very cool that this is where we are in the tournament. The Elite 8 kind of rounding out. We're down to just 8 people. It's crazy. Juiced from the blue bracket, October 21st, is going to go up against Victor K. Victor K is a very speedy SolidWorks user. Juiced is a very speedy ANSYS Space Claim user. And we're going to find out. You know, a lot of people are saying, oh yeah, ANSYS Space Claim is fast, but only when the geometry isn't complicated. Well, in the round of 16, the geometry got more complicated. In the Elite 8, the geometry is going to get even more complicated. So we're going to find out if that's true or if Juiced is able to just cruise right through, no problem with that more complicated geometry. We move down to the red bracket, and in the red bracket, we've got the Onshape wizard Imants, who has moved through the rounds of 32 and 16, and is now in the Elite 8, and it's going to square up against Jihan Rafa from Egypt. Jihan was in the epic match that we showed this weekend, October 7th. Went 4 rounds, really good match, and the last person from Egypt, with the last Egyptian standing in this tournament. So good luck to Jihan Rafa. She has been absolutely crushing it. She got through the round of 32. She got through the round of 16. She is now in the Elite 8. And congratulations to Jihan moving through that. And of course, also to Imants. Then we move over to our green bracket. And in our green bracket, we have got Aaron C. He's in the chat today practicing. Looks like he's battling with Airwick a little bit. And Aaron C. is from the United States using SolidWorks, going up against Pranav from India using SolidWorks. So our only SolidWorks versus SolidWorks battle here in the Elite 8. So very interesting, very exciting time. Very thankful to have some pretty epic sponsors. We got Joko Engineering sponsoring the black bracket. We got SolidBox, www.mysolidbox.com, sponsoring the blue bracket. We got REVOPOINT 3D scanners for all mechanical engineers. REVOPOINT3D.com sponsoring our green bracket. And we got Alibre sponsoring the red bracket. Alibre.com. They make powerful yet easy to afford 3D CAD software that you own. You purchase it and you own it. They offer a perpetual, forever, lifetime license when you purchase Alibre. Check them out, Alibre.com. And if you want to see Alibre in action, you can watch the match, the very first match we did in the tournament with Ty and Fabien Pierre. Hey guys, we got Jason Cannon in the chat. What is up, my brother? Welcome. Thanks for joining us today. Great to see you in here. As some of you know from the tournaments, Jason is I guess you would call him my CAD mentor. He's really helped me kind of figure out my way in the world of CAD and 3D CAD. So, and truly an old friend and somebody who I'm very glad to see in here in the live stream today. What is up, Jason? Thanks for joining us, bro. All right, guys. So let's move on now. Oh, John is here as well. Jern. Welcome, Jern. Thanks for joining us. Got a nice sheet metal challenge for you there for that first challenge. So again, huge thank you to RevoPoint sponsoring the green bracket, Alibre sponsoring the red bracket, Joko Engineering sponsoring the black bracket, and MySolidBox.com, SolidBox sponsoring the blue bracket. SolidBox crew is coming out on November 11th for the finals, and I think really everybody is trying to get to the finals because with this sponsorship, we've got some epic prizes up top for the top 4. We've got cash money, USD anyway, $125 USD each for 3rd and 4th place. So whoever, becomes the champion of their bracket is going to lock up $125 USD. 2nd place, the runner-up is going to get $250 USD. And 1st place, $500. That is a lot of money. So $500 USD up top. Congratulations to all of our runners, and good luck everybody getting to the Final Four. But that's not all. You know, that is an epic prize with the help of the sponsorship from SolidBox, with the help of the sponsorship from Joko Engineering. But that is not all we've got. We've got some additional prizes. A Libre, really coming through. Powerful yet easy to use 3D CAD that's affordable. A Libre said, we want to give CAD to everybody in this tournament. So all of our runners are going to get, everybody who participated in the tournament is going to get a seat of a Libre Atom 3D, a lifetime license up to third place. Second place is going to get a Libre Design Pro lifetime license, and first place, the champion, is going to get a seat of a Libre Design Expert. So totally epic seeing our sponsors coming through and seeing a Libre saying, we just want to give CAD to everybody. We want everybody to have 3D CAD. Joan Benji in the chat saying, how do I participate next time? Great question. So our goal is to have the registration for the next tournament open by the time we get to November 11th. So we're going to try and make sure that when we get to this the finals of the tournament, that the next round of qualifiers is already up and running. So just kind of stay tuned, Johan Benji. Just stay tuned, and when we get to November 11th, you're going to get the notification. You know, subscribe to the YouTube channel, follow me on social media, join the TooTallToby website. We're going to send out kind of like a newsletter, let everybody know what's going on as well. So join at the TooTallToby website, but basically just follow me online. We'll definitely let you know. What CAD system are you using, Joyan Benji? Just out of curiosity, what are you using? I'm taking a sip of my delicious drink here. I think next year we're going to try and get Waterloo to sponsor the tournament. We're definitely going to have Waterloo at the live event. Victor K is here. What's up, Victor K? Welcome, welcome. Oh, all right, sweet. Katia V5. Yeah, we had a Katia V5 runner earlier in the tournament. Muhammad was a Katia V5, or is a Katia V5 user. He's in the blue bracket. So he made it into the round of 16, but he fell to Juiced. So Muhammad here is a Katia V5 user. So you can go back and watch some of the episodes with Muhammad, and you can see him totally rocking it with Katia V5. So not only do we have prizes for the top 4 from a Libre, really for all the runners, but we also have prizes for the top 4 from REVOPOINT. REVOPOINT specializes in creating 3D scanners for all mechanical engineers, really all engineers of any sort. And they offer a variety of affordable, high quality, high accuracy 3D scanners, as well as post-processing software. So after you're done creating the scan, software to help turn it into an STL or some other form of mesh that you can actually then use. So REVOPOINT, you can visit them at revopoint3d.com. They have put up prizes for our top four finishers as well. 4th and 3rd place are going to both get a REVOPOINT Inspire 3D scanner. 2nd place is going to get a REVOPOINT Range 3D scanner, and 1st place is going to get a REVOPOINT Mini 3D scanner. So these are some epic prizes up top here. Be sure to check out the description in the link below, or in the description, there's a link to sign up for the Miraco REVOPOINT 3D scanner. This is a new scanner they're coming out with. It's an all-in-one scanner. So it's got the processing tools built right into the unit. So you don't need a computer or a phone to perform your scans. You can do all of the scanning right from this all-in-one device. And it also has lenses that facilitate both large format and small format scanning. So it's really kind of like an all-in-one scanner solution. If you're considering purchasing a 3D scanner, maybe check out this link in the description. Sign up for the Kickstarter Super Early Bird Special. You can get 40% off. That's a good way to start your collection of 3D scanners with a nice 40% off discount. So definitely check it out. Check it out at the link that's down in the description. Sign up today, and you can make sure that you get notified. I think that Kickstarter begins October 25th. So check them out, and huge thank you to REVOPOINT. They are an excellent partner in this tournament. Yeah, Victor makes a good point. I'm sure that it would be an interesting comparison. Be cool to see what they have and what they don't have. All right, guys, that's pretty much it for the summary of the tournament. Congratulations to everybody who made it into the Elite 8. It's great to see Victor K in here. It's great to see Aaron C in here from the Elite 8. Also great to see Will in here. Great to see I know there was somebody else who was in here from the tournament who had been in the tournament a little earlier. I'm sorry if I'm missing you right now. I'm just kind of going back and looking to see who it was. Thought I saw somebody sneak in who was in the tournament earlier as well. But great job to everybody who's been in the tournament this year. Congratulations. My team's just finishing up that Libre form. So for you, Will, you should get that email this week sometime with the form for the Libre lifetime license. And that way we can get your info, get that over to Libre, and get you all taken care of. So, all right, guys, let's take a look here. I think what I'm going to do is I'm going to start out with this one. Our runners really had a lot of trouble with this one. So what I'm going to do is I'm going to get in here to Onshape. I'm going to model this thing up. I've been having a lot of fun in Onshape. You can see some of the stuff I've been modeling. All the stuff that I build is in the public space, so you can always search for it in the world of Onshape. Here you can see I did a little bit of migration from SolidWorks to Onshape. Little sneak peek here of an upcoming tech tip that I've put together for the Onshape video series. So little migration here of an assembly from SolidWorks into Onshape, fully functional. Had lots and lots and lots of mates in SolidWorks. Was able to do it with just 6 mates here in Onshape. So 3 groups, a Revolute, and a gear mate, and boom, we are done. And of course, the cool thing about Onshape is that you can always just right click on a mate and choose animate. And then you can just kind of like let this thing rip and watch how this thing would function in the real world, which I think is just so cool. It's kind of a pain to do that in SolidWorks with the animator. I don't know if you guys ever work with the animator timeline. You run into some challenges sometimes. It takes a little getting used to. You can definitely get there, but I was very happy to see how easy it was to kick these files out of SolidWorks, bring them into Onshape, and actually get a functional assembly pretty quickly here. The animator is a beast. Yes, indeed. All right, let's keep going here. We're gonna take on this model here. We're gonna try and do this in the next 5 minutes. We're gonna give ourselves a 5-minute. I wish I had the 5-minute clock here. I'd put it on for everybody to watch. But the model here, when you look at a model, anytime you look at a model, you know, when you're doing the TooTallToby challenges, usually the first thing you do is you grab a screen capture, and you then want to, you know, first of all, look at the print and ask yourself if the designer or the drafts person left you any information that'll maybe help you. And so in the case of this model, there is definitely some information that'll help us. The model is symmetric. You know, that's definitely going to help us just in terms of locating one of the planes. So one of the planes is going to run right up through the center here. And I know Jason is in the chat today. Jason, if you see me doing anything that you think you would do different, feel free to let everybody know. I can still learn, I'm sure, from you. So, you know, just feel free to let anybody know. But you know, I think that one of the first things I would notice is that we've got these lines of symmetry. That's going to help us locate one of our planes. Our central plane is going to run right up through here, right up through the middle, and that's gonna really help us. The next thing that I think I'm going to notice from the drafts person is that we've got this 6mm wall thickness kind of all over the place. So 6 millimeters, 6 millimeters, 6 millimeters. There's even, I think there's a note on here somewhere. Here it is, 6 millimeters wall thickness typical. Now, when we have that note, what that says to me as a mechanical 3D CAD user is shell. Yeah, Eric is saying it in the chat. Shell is key. And this is something that both of our runners really struggled with when they were trying to build this part. And I think that's the biggest reason why, is because they missed that kind of indication that there's going to be a shell in this model, and they try to do it as a hollow part right from the start. You really want to do any of your solid features, so extrusions, lofts, any of those types of features first, and then go back in and add the shell. And so if you go back and you watch that match between Jihan Rafa and Jack Sato, you can see them really struggling because they started out with a hollow or a thin feature, and then tried to use that hollow thin feature to loft and to sweep, and it got really, really messy. And so I think what I would do with this model is I would start out with this shape here, this 200 by 50. And once I do this 200 by 50, what I would do is I would extrude that up to a height of 50 millimeters. Then I would create a new plane here at 180 millimeters off the top. And once I create that new plane off 180 millimeters, I'm going to create this shape here, this section CC. So we can see here, we're getting this indication of section CC also being 180 millimeters up. And for this one, I'm going to create this with a 110 by 90 millimeter, like a slot feature essentially. And then I'm going to take that shape and I'm going to extrude that up to a height of 20 millimeters. And once I've got that shape extruded up to a height of 20 millimeters, I can just take that profile, rotate it around 90 degrees with a 30 millimeter radius, and then I can finish off by extruding that to 40 millimeters. And once I have that shape in place, then I will shell it, but not before. If you try to shell this thing out before, you're just going to end up struggling. So that's my game plan. I know I burned off 3 of my 5 minutes just kind of coming up with the game plan. So let's see if I can't model the rest of this in just about 2 minutes. I might be pushing it a little bit, but we'll see. We'll see what kind of power Onshape holds for us. So 23-T-59-duct. Whoops, nope, duct. Sorry, guys. That's probably how our runners felt as they were trying to create this geometry. And then we're going to say that this is going to be a public document. So if you want to search for it, you can. Top plane, begin to sketch, orient my view. And I'm going to start out here by creating a sketch of a line. And that line is going to have a distance of, let's see here, it's going to be 200 minus 75 minus 75, so 50. So 50 millimeters for the length of that line. And then I'm going to just take that line and take the origin, and I'm going to assign a midpoint relationship between them. And then I'm going to select that line and jump into the slot command. And I'm going to create a slot here, which has a dimension across at 90. And the 50 there is already solved. If I wanted to just take a quick kind of like a sanity check dimension, I can just dimension here to these arcs, and I can see that that's coming out at 140. Nope, that's not right. That should be, oh, I was looking at the wrong section view there. So this is going to be not 90, 150. There we go. Okay, so there's my sanity check, 200. That is correct. And now I'm going to take that geometry and do an extrude, and that's going to go up to a height of 50 millimeters for that first part of my game plan. Now I'm going to take the top plane, and I'm going to jump into the plane command, and I'm going to say I want to offset that to a height of 180. And so there's my second plane there. And now I'm going to start a new sketch on that second plane. And for this new sketch here, I'm going to create, once again, a line. This time the line is going to be kind of over here. And this time the line is going to be 110 minus 90. So it's going to be 20. So just doing some quick math here in my head from the 2D print. And then this line is going to have a... Let's drop a point on here so we can easily make a midpoint. I know there's other ways we could align that to the origin, but I'm just going to take this point here and give it a midpoint relationship. And then that'll make it a little easier for me to take this point and the origin and make them horizontal. And now, whoops, make them vertical, let's say. So a little Control-Z for undo. Good to know that Control-Z works here. So we're going to make those vertical. And then there is a dimension on the print here to help me understand what the center-to-center distance is. And that dimension is 75 millimeters. So I can assign here this dimension 75 millimeters so that I know that those line up at 75 millimeters. And then we're going to take this line here and go into our slot command once again. And this time our slot is going to have a distance of 90. There we go. And now what I could do is, let's just make this line construction just to make sure we don't run into any hiccups. I can jump out of that sketch, jump into a loft, and say I want to loft from this geometry to this geometry, and boom, there we go. That's exactly what we wanted. Now in Onshape, I don't have to create a new sketch. I can just take this face here and extrude that up to a height of 20 millimeters. And then I could probably do some kind of a transform here, but I think what I'm going to do instead is I'm just going to do a use here. So I'm just going to take this, let's do a right mouse button, select tangent connected edges, and do a use. And then I'm going to draw an extra line out here. And I'll make that line a construction line. So I click on the line here and do a Q. And then we're going to say that that's going to be at a distance of 30 millimeters. Don't need a sketch. Eric says don't need a sketch here either. Yeah, how would you get the location of the rotation? I'm not saying you can't. I'm just saying could use a make connector for the center. Okay, nice. I like it. That's good to know. So I'm going to use this sketch here for the revolve. I'm going to use this for my revolve axis, and I'm going to say that that is going to go to an angle of 90 degrees. And you can see here that that's a different color. That's kind of Onshape indicating that you made a new body instead of adding to the existing geometry. So I'm going to add to the existing geometry. Now it is showing up as red, which is kind of interesting. I wouldn't have expected that. Huh. Interesting. So, okay, let's do it as a new body. It says you're in a surface. Okay. Ah, thank you. What would I do without you, Eric? All right, so we're going to do a revolve here. We got the edge of the sketch. We're going to do this as an add, and we're going to say it's going to merge to here. There we go. It was on the wrong tab there in the feature. Thank you very much. And now we're going to take this face and jump right into an extrude from that face. That's going to go out to 40. And we're going to say that's going to be the end of that feature. And now we can jump into a shell. We can use that 6mm shell option to shell this thing out all the way through. Yes, 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 that looks good. And now we can take this face here and we can begin a new sketch on this face. And then we're going to do this entire face here. We're going to offset its geometry. So offset that, and that's going to get offset to... See, this one has a dimension on it all the way across. It's got this dimension of 150 by 130. So it looks like that's going to be an offset of 20mm. So I can just click out here in the background if the direction is correct, and then I can type in the distance 20, and then I can do an extrude, and that's not going to be the entire sketch, but instead it's just going to be this region extruded to a depth of 20mm, and I'm going to reverse the direction. I'm just kind of doing some quick math there in my head to get the the depths of some of these features instead of using the math function. I could have used the math function as well. And then finally, I'm going to come down here to the bottom of the model. I'm going to create a sketch of a rectangle like so. And once again, we're going to line up these points. So this point and this point are going to be vertical. Say vertical. Okay, good. And then I could do mirror. So we make this Q, and then we could mirror this across, or we could do it at the mirror at the feature level. You can do it either way. And then we're going to probably actually better to do it at the feature level, but in this case, I don't think it really matters that much. And then if we look at that detail or that top view, we can see that that is supposed to be 38mm, and the distance to the center is 95. So distance to here is 95. And then we're going to extrude that. That's going to go up to a height of, I think it's 20. Yep, 20 tabs. And then we'll finish off with a fillet. And that fillet is going to be at 10mm. So fillet there, fillet there, fillet there, and fillet there. All right. And now we're ready to assign a material. So assign material. This is going to come from the TooTallToby material library. So if you guys ever want to do this yourself, you can actually access that library in the public space in Onshape. If you have a free account, you can access all that. And I'm coming up with a mass of 1068. Let's take a look here and see if we got it correct. Oh yeah, 1068 is the correct answer. Good job, Toby. You're excellent at modeling these parts. You should enter the tournament next year. So that's how we do it. What's up, Sahil? Welcome, welcome. Thanks for joining us. Onshape supports 3D Connection Space Mouse. Yep. Got to get that. I do have a 3D Connection Space Navigator. I just need to get it up and running. All right. Just reading through some messages here. Looks like everything is good. All these messages are good. Joho says 7 minutes, 20 seconds. Not bad. Thank you. Thank you, Joho. Appreciate it. All right, let's take a look here and see who got the answer correct to our first challenge. Don't forget, guys, if you like this kind of content, be sure to hit that like button. Looks like we got 32 people watching. Looks like we got 16 likes. Let's see what we can do to get those numbers to match up. Very, very helpful. When the episode's over, if you come back and put a comment and say, this was a great episode, something like that, that's always super helpful too. Even though I know you guys are watching live and I appreciate all of the chat activity, it's also helpful if you come back and leave a comment afterwards. And don't forget to subscribe and share this and hit the like button. Yep. All right. Whoop. I almost showed it, guys. If you were quick, or if you pause it, you can find the answer. All right, so let's see here. I saw the answers coming in the very beginning. I saw Aaron C, and Eric were battling it out. So let's take a look here and see what we got here from these gladiators, really. So Eric coming in 501. Aaron Christensen 499.2. Eric says forgot the chamfer 498.89. So we'll call that 499. Both of them coming in with 499. Aaron C 499. Will 490. Very nice, very nice. Striker coming in 503. Striker revising 505. Airwick 499 coming in again. The animator is a beast. Yep. Shell is 100% the way to go. Yeah, the two inside lines will really mess you up. Yeah, they're on like a weird, like funky angle. Yeah, it's almost an optical illusion because both those dimensions are at the same height. Just kind of reading through the chat here as I'm going through. Exactly what I did when I did it live. Went back and did it with a layout side sketch. It's a bit more intuitive. Yep, that's cool. All right, Mustafa is here. Welcome, welcome. Thanks for joining us. Okay. So 120 on section A refer to the inside of the outside of the shell. It refers to the 120. I think it's 110. 110 or 130. Either way, it refers to the outside. Oh, section AA. 120. Radius 120. Yeah, that one, that is a little bit gnarly. That does refer to the outside as well. The only way you can really figure that out is if you add 30 and 90 and then cross-reference the other section view. But yeah, that refers to the outside. I feel like it's pointing to the inside, but that conflicts with the 90 dimension. Yeah, that was a tough dimension for me to draw because I wanted to show that it was coming from the same radius. Yeah, you guys got it. All right, Sahil is here. 7 minutes, 20 seconds. All right, cool. Chris Knudsen is here. Welcome, welcome. Striker, I had the wrong material. $4.99 once I chose the right one. What's the correct answer, guys? Correct answer is 499 grams, plus or minus 2 grams. So congratulations to Aaron C. continuing his domination of Model Monday Live. Well done, well done. Aaron C. gets the point today. GG, GG to Aaron C. Oh, wait. No, it is Aaron C, right? It was Aaron C and Airwick going back and forth. Airwick 501, Aaron C 499. Yeah. Congratulations, Aaron C. Well done, well done. Everybody give a GG in the chat. GG to Aaron C. And we're going to get into this next challenge. 21st and 28 are going to be an epic battle. Yes, indeed. Yes, indeed. My comment on the duck print. Maybe too many reference dimensions. Yeah, I agree. There's a lot going on that print. I completely agree. Too much. Too many dimensions. We're getting into the elite, the elite 8 here. Sweet 16, elite 8. We gotta make sure that we give these guys good challenges, but there's other ways to give them challenges. All right, guys, here we go. Second challenge for all of you wonderful people out there. This next CAD challenge begins in 3, 2, 1, go. Here we go. The toy mic. This is a good one from the old days. Fun one. Fun one for you guys to try to model up. There's a little bit of trickery in this one. What is the mass of this part in x.xx pounds? IPS using ABS, the plastic part. You can print this out. Give it to your kids and say, hey kids, you host live stream tournament events. You can host live stream tournament events too when you get older. Just like your old man. Might not be that applicable, depending on how frequently you host live stream 3D CAD tournament events. But it is still a fun part to draw up. How would you model this part? If this was you, challenged to model this, how would you do it? A little bit tricky at the bottom. A little bit of construction line geometry down there. It is really a flat spot at the bottom, technically, but I use some construction line geometry to give you guys your dimensions to the virtual round. The virtual round on the bottom. All right, guys, we're going to move on here. Hope that was enough time for you to grab a screen capture. If not, this is your final chance. Then take a moment and feast your eyes upon this flyer. Look at how epic this flyer looks. Remember last year when Allness and Tom Smith were in the semifinals together and they were battling it out in a giant arena? I sure do. November 11th, Lansdale, PA, CAD vs. CAD World Championship Finals in another massive conference center. Maybe not quite this big this year. We'll see how it goes. Look how epic that flyer looks. If you guys want to sign up for this, if you guys are going to be in the Pennsylvania, United States area, or if you want to just fly out to Pennsylvania, United States on November 11th, we're going to go 10 a.m. to 3 p.m. It's very easy to get to from all the local airports. And you can show your interest at TooTallToby.com/finals. That's TooTallToby.com/finals. And let us know, let us know if you can make it. And let us know if you have any thoughts about the event. And we're still trying to drum up interest, trying to get a head count. So if you think you're going to be in the area, if you want to hang out with us, the competitors will not be there with us live. We'll just be live streaming, but it's great to have a live studio audience. We did this last year. We had a great audience. We had Green Shirt Guy. Green Shirt Guy was getting coffee many times. He got coffee many times. People were counting how often he was getting coffee. So Green Shirt Guy is coming back. He has confirmed. And we'll see who else is able to make it. Bodie McBoatpants is going to be there. So if you guys want to see and hang out with my web dev. But just look at that flyer. It looks so awesome. Then we're going to crown a new world champion. So that's pretty exciting too. Tournament finals, November 11th. We're all looking forward to that day. I also did an interview with Joko last month. So if you guys want to check out Joko Engineering, his YouTube channel, pretty fun interview with Joko. Still working on the tips page. The September leaderboard runs are all up and posted. We're going to pick a winner from September. We're going to try and get the October leaderboard up and running. Like I said, we might skip October and just go right into focusing on getting the next qualifier leaderboard up. We're going to have that next qualifier leaderboard run for several months. It's not just going to run for 1 month like we did this year. We're going to have it run for multiple months and, probably 2 to 3 months. And that way we can start the tournament in January or February of next year, start the next tournament. So what's up, Steve? Welcome. Nice job. Good job. That was a tricky part, that sheet metal part. Nice job getting it. I saw Stryker got it too, right, with the correct material. So nice job. Nice job. Been teaching some classes last month. This month, I'm going to be teaching some part modeling, some assembly tips and tricks, SolidWorks classes. So if anybody ever is in need of any SolidWorks classes, reach out to me. Let me know. We can try to make it happen for sure. Been enjoying this, putting together some content that we can use in the TooTallToby community as well. All very exciting stuff. So check it out if you ever want to get some training. Let your company know. All right, guys, I want to do this part here in Onshape. This is a sheet metal part. I think I'm going to make a proper tutorial for this one as well. I think I posted a practice model using this part, if my memory is working correctly. So I think there is a practice model of this part, but it's slightly different. Some of the dimensions change. So I'll probably make the video tutorial on that. But today we can take a look at this using Onshape. And so just like as I did in the previous example, and just like as always, what you want to do with a model like this is you always want to start out with kind of a game plan. So again, we look to see if the model is symmetric. And the reason that's important is because that's going to help us define where the origin should be. So the origin should definitely have a location along this plane here. And we should model whatever we can on one half of the model and then, just mirror everything, save ourselves that extra effort if it looks like there's going to be an extra effort. I think that there is in this case. I think there is kind of an extra effort that goes in constructing this leg here. So maybe just modeling half of that, just creating that leg once and mirroring it across will save us some time. The next thing we need to decide is what is going to be our starting plane and what is going to be our starting profile. And we can again, use our engineering intuition to decide on an ideal location for the origin. So for example, there's this 40 millimeter dimension here that's coming from the back of the part and helping us locate this flange here. And then there's also an 80 millimeter dimension here coming from the back of the part and helping us locate this front section of the model over here. Well, if that's the case, then maybe it makes sense for us to create this geometry with the origin on this back wall as well. So now we kind of know where the origin is going to be. It's going to be centered on the model. It's going to be against this back wall of the model over here. And maybe the lower part of the origin could just be right here, kind of located where this lower flange is. So now that we've got all that, basic idea of where we want the origin to be located, we can now get in here and start defining what our first profile is going to look like. And this is where things get kind of interesting, because you could make the argument that this should be your first profile, or you could make the argument that this over here should be your first profile. This shape kind of coming across here up over, really we'd only create half of that shape. I think those are both completely valid ways to start, but I think that the reason I would opt to do this as my profile first is simply because I think it's going to be easier for me to make that as a sketched profile, especially this bend here, than it would be to create it with multiple bends, like an edge flange and then another edge flange. So I think for that reason, I'm going to create that as my first sketch in Onshape. So here we go. My clock's showing 1:49. I want to make sure that I get you guys the correct answer. So let's try and do this in 5 minutes again. Not so much a tutorial, a little bit more of a speed run, but it could be looked at either way. So I'm going to close this model that we were just working on. I'm going to begin a new document here. I'm going to give this thing a name. This is going to be called 23-T-55-through bracket. That way, if you ever want to look at this model, all you got to do is sign up for a free account on Onshape. Right plane, begin a sketch, orient my view. And once I get that view oriented, I'm going to create that kind of angle coming down, straight down section coming across here. And then a section coming up like so. And now I'm going to get in here and start adding some dimensions. So the dimension to the origin here, kind of like what we talked about in our game plan, the dimension to the origin here is going to be that 40 millimeters that's going right to the center of that slot. We'll see if that'll help me out. The dimension from the origin to the lower part of the material, or the very bottom of the model to the lower part of the material, is 30 millimeters. The dimension to the upper part of the material here is 70 millimeters. 70 millimeters to that upper part of the material. The dimension from outside to outside across the outer parts of the material is 80 millimeters. This is at an angle of 45 degrees. And the section from the lower side of the material to the tangency point here is 20 millimeters. Wow, this might actually not work out the way I'd hoped it would. I think I might actually have to make this as a separate flange, or it might just make more sense to make it as a separate flange. I think it's because of this 20 millimeter dimension here. I mean, we can look at it. Let's just do it first and measure it before we completely rule it out. But I think I might have to go back and do that a little bit different. Yeah, now what? Yeah, exactly. Yep, I'm thinking that too, Eric. Eric knows the challenge that I'm setting myself up for. So here we go, sheet metal model. Let's do extrude, and let's take this geometry here. Let's kind of roll this thing around. One thing you always have to look out for when you're working with sheet metal is making sure the material is on the correct side. This is 4 millimeters and 4 millimeters for those two parameters there. And let's hit the depth to 84/2. So 84/2, because we're just doing half the model per our game plan. And now let's take a look at this measurement here. So the measurement from here to this flat spot looks like it's got a parallel distance of 18.34315. So I could add that difference if I wanted to. I've definitely done this in speed modeling challenges. It's not exactly the most elegant solution, but I could do this here, this 20. I could say 20 plus parenthesis 20 minus 18.34. I don't remember what the rest of it was. 13, something like that. I definitely could do that. That would be, is it gonna let me accept that? Maybe not. It's not gonna let me accept it. Let's see here. can I take this and then add 20 to that? What did that end up being? 1.66. I'll just make it 21.66. Boom. We're speed modeling. This is not the way you'd want to do this in production for sure. You'd probably want to do it the other way. Okay, there we go. Look, parallel distance, 20 millimeters. I'll take it. All right. So now what I need to do is get rid of this extra material here at the same height as this material over here. So I could just start a sketch there and create, you know, maybe like a parallel or an angled rectangle. So we could do something like this. Create an angled rectangle, and then we could take this point and make it coincident with this edge here. There we go. And then I'm going to remove that material. So that's going to be a remove. Let's reverse the direction there and take that through. Okay. That looks good, as long as you don't look underneath. Close enough. Yep, exactly. Eric is saying close enough. I agree. All right, now we're going to create an edge flange here. So in Onshape, we do have the option to create a flange. And we're going to be using this option here for flange alignment for hold line, a little bit of a newer bit of functionality that was added to Onshape. And so we're going to use that hold line option. And then for our end type, this really could just go up to entity, and it could go right up here to the top plane. Just to kind of come up flush to the top plane. That certainly is an option. And then for our flange option here, we could say this is going to be a partial flange, meaning it's not going to go the entire distance of the flange. And we can even do that on both sides. So we could say that we need this to, you know, to come in a little bit from either side. For the end condition option, it could be the end condition from the edge here, or, you know, the print is saying make the end condition from this end face here. I think I'm just going to do the math in my head. So it's 20 millimeters minus 4 minus 4. So it's 12 millimeters off of each of those. Off of each of those. So 12 millimeters off of that one and 12 millimeters off of that one. Is that right? 12. It doesn't look right compared to the print. I guess it's actually, maybe it is calculating it from the original hold. That's kind of nice. I'll do a quick check there. One of the nice things about Onshape is that if you just pick two surfaces and you look down here, you can see the distance between those two surfaces. You don't have to go into a special mode or anything. SolidWorks has that too with the status bar. I talk about that a lot in my SolidWorks power moves. So, okay, so that's what we needed, was at 20 millimeters on each side. And now we can continue on here, and we can take this, this edge down here and do another flange. Now this time when we go to do the flange, we're going to use the flange alignment here for outer. And if we look at this thing from the front, we can see what that's doing. It's aligning it flush to the outer material of the flange is aligned flush to where the original edge was. So now we just need to take this out to the correct depth, and this is going to be, wow, this might be a spot where I would also just like overshoot it and then come back. It's probably easier if I created some type of layout geometry to have this aligned to, but in lieu of that, I think I might just end up kind of lopping off the extra and adding the whole all in one step. So I think I'll just make this go out to 70, and maybe I'll make it go a little bit more, 90. There we go. And then I'm going to go to this surface here, begin a sketch, orient my view, and I'm going to create a line here that comes down to, you know, about here. Come back and, oh, you know what? I don't think I can reverse the tangency with the line in Onshape. I think I have to actually make it tangent using this technique. So we'll make that tangent, and then we'll do another line on this side. Make that tangent. And throw that hole in there. And that's going to have a diameter of 20. And then all I need to do is add the distance dimension from here to here. And that is 172/2. Now I can do a remove. And that'll just go through all or up to next. Yeah, that works. And we've got our chamfer here. Almost done with this thing. This is 30 and 30. And that's on this edge. Let's see. Doesn't like that, huh? Maybe if I make this 60. Chamfer might not work. Yeah, I've noticed some features don't seem to work in sheet metal yet in Onshape. So this might be one of them. So we'll make this, whoops, wrong dimension there. Make this 30. Here we go. And then we'll make this 30. Okay, and we will once again remove up to next. And then on the other side, we've got a couple of fillets. So we'll do our fillet here. And that's going to be at 10 millimeters. And then we've got our 12 millimeter diameter hole. And that is going to be at an offset distance of 3rd time's the charm. Interesting. Not seeing my dimension. Well, that's a little bit unusual. I don't know that I've seen that before. Maybe if I just go from the point, it's... Yeah. Okay. I don't have an explanation for that one. We'll do a remove. We'll go up to next. And we will... Next. And we will mirror. And we're going to be doing the full part here. Mirroring the full part here. So this part across this face. And we want to make sure we do this as an add, so we end up with one single sheet metal part. And that's how I would go about modeling that part. This is once again going to be asking us to assign a material here. So our material is going to come from the TooTallToby library materials. It's going to be a plain carbon steel. And that is going to come out to a mass of 568 grams. Let's see if we got it correct. If we did, we're awesome. If we didn't, we'll have to fix it. Fix it another time. 507 is what it's supposed to be. 568, 507. Oh, I didn't do the slot through the middle. Still missing that cut down the middle, yeah. So get that cut down the middle. I'm sure that we could get that to be the correct thing. I'll come back and do that in overtime. I know that a lot of you guys have to leave, so I want to make sure that we recognize the winner of the challenge. So I will come back and do that before I end the stream today. But don't forget, if you like this kind of content, be sure to like, be sure to subscribe, be sure to add some comments, some chats. It goes a long way towards helping. If you want to get more practice like what we did today, check out the practice models playlist. There's over 80 models on there now that you can sit there and just binge and practice your 3D modeling skills. And so let's see here who answered this one correctly. Let's go back up here. Looks like, oh, good. We got a lot of good answers here today. This is awesome. So looks like our first answer came in from Airwick, 2.16 pounds. Victor K, 1.97. Aaron C, 1.97. Airwick revising, 2.14. Airwick, 1.97, revising to 1.97. Let's see what else we got in here. Striker, 315, 18.343. Maybe a little bit off there. Jern coming in 1.97 using build 123D. Awesome. Omri is here 1.97. Very nice. Very nice. Very nice. So the first person who answered was Airwick 2.16, and then Victor K 1.97, and then Aaron C 1.97. Correct answer is 1.97 pounds. Very nicely done. A lot of people in the chat got it correct today, so nice job to everybody who got it correct. But that's going to give that point to Victor K. So we got both Aaron C and Victor K in the tournament still, battling it out, and they both got a point today. So very nicely done. GG to Victor K. GG, Victor. Well done. Giving me the dimension I was asking for. Okay, cool. Thank you. Appreciate it. All right, congrats to our winners today. Great job. Don't forget to check out mysolidbox.com. Professional, no IT required computer solutions, mysolidbox.com. Check out the Onshape YouTube channel. I've been doing a series of videos on there. Got a bunch more in the can, ready to be released. So check it out. SOLIDWORKS Expert learns Onshape. Thank you to the amazing chat. Thank you, James DeBano, for joining us today. Finally caught your live stream. Next time I'll try to join in. Cool. Guys, don't forget, Victor K, who we just talked about. Victor K, who won the point today, is going to be competing in the Elite 8 October 21st. Not this Saturday, but next Saturday. So be sure to hype that up. Share it with your friends. Share the link with your friends. If you see me posting anything on social media, share it with people. Try to tell your coworkers to tune in. It's going to be a lot of fun. October 7th, we're going to get a lot of people in there. Victor K is scary fast, yes, but so is Juiced, Aaron C. So that is going to be that's going to be amazing. I'll bet that whole live stream is going to go for like 15 minutes because of how fast everybody is. So it's going to be really good. It's going to be awesome. So thank you guys so much. The most amazing chat ever. No tournament this Saturday, but we will do Model Monday Live next week at 1 p.m. It's always good seeing everybody in here. It's always fun doing these challenges. Don't forget to come back after the live stream is over and just throw a comment in. Say, today's episode was really good. It's always good to help with the algorithm. And like I said, I'm going to stick around in overtime here and just try to fix that slot so I can get the correct answer. But if you guys have to leave, I understand. I hope you have a great rest of your Monday. I hope you have a great week. And I hope that I will see everybody next week in Model Monday Live. Nuno, what's up? See ya. See ya, see ya, see ya. And like I said, I'm going to just go back in just because it's important to me to get this kind of stuff right. So I'm going to create this sketch of the slot here. In Onshape, we can come back, touch the endpoint, come around, and give ourselves a slot that way as well. You could do it with a center line and create a slot like what I did earlier. It's probably up to the individual to figure out which technique is better for them. It's like this is 15 across. Look at that, I got almost perfect just by eyeballing it up. And then it looks like we've got a dimension of 52. Actually, it's to the center of that slot. I always forget that if you want the center, you pick the actual center point as opposed to the arc itself. Okay, let's do an extrude cut. This is going to be a remove through all. Rip that thing through the whole model there. As always in Onshape, you can come over here to the sheet metal table and kind of see what this thing would look like in the flat. It's kind of cool that you can work in the flat and in the formed at the same time. So just another little benefit of Onshape. Let's go here to our properties and boom, 507. We did it. We did it. Yes, thank you. We did it. We did it. We did it. We did it. Okay. Excellent, excellent, excellent. Thank you guys so much for joining us. Thank you guys for sticking around in overtime. I think that's going to do it. Enjoy the rest of your Monday. Enjoy the rest of your week. Everybody stay safe out there. I know there's a lot of crazy stuff going on in the world right now. So stay safe. Keep your family safe. And look forward to seeing everybody next Saturday in the tournament. Next Monday in Model Monday Live. See you, everybody.